All right, so. All right, so how am I coming across to you fellas tonight? This afternoon. Y'all hear me okay? Okay, so we've got chapter 10 to finish up today, just to get you familiar with the calendar. As I tell you, I mean, I tried to show you this, but this should be something you're very familiar with because this is how we go. And I had mentioned the last time that since we were, since it's going to be too much crammed in next week for you Tuesday, Thursday folks, I was moving ahead a little bit quicker, and we should be able to finish all the test material for Thursday, and then next week on Tuesday, the 27th, there'll be a review, and then tests due like the Wednesday, and then Thursday, the last day of class, is our review for the final exam. And just remember, you got that final exam. It's the proctored thing, so make sure you got no issues with that. There's warnings that go out about when people actually did the practice runs. You got to make sure you're adhering to those rules and such about what you're using for a calculator. You got to keep your face on camera. You can't be talking to people. So, because that's just a little over 2 weeks from now. Okay, so I'm going to assume if you got questions, just let me know. I mean, type them in now because I want to get going on this so we can finish up this chapter 10 thing. This is really not that tough. This was the example we looked at briefly last class. You've got a radical equation, essentially. It's got the square root of 3x minus 2. Then negative 8 is outside the radical, and it's equal to negative 1. Now, with a radical inside, there's no way to get the x out with anything we know so far. So we're using the fact that if we square a radical, it pops out. In other words, that's what that's based upon. But it can get pretty messy if you have something else besides the radical on one side of the equation. Okay, so what we got to do is take care of that negative 8. Neutralize it by sending it over to the other side. All right, so negative 8 plus 8, that gets rid of that, but we got a plus 8 on the other side, so we end up with negative 1 plus 8, which is 7. Now you got your radical isolated. Then when you square, you're not going to have so much of an issue here because it's going to be nice and neat. Believe me, you don't want to do this where you have to square like this because there are some that you're forced to, but we don't cover those. So when we square the square root, the insides pop out, and on the right side we're squaring 7. So square root 7 squared is 49. From then on, it's just a plain old equation. We solve it and we find that x is equal to 17. Now, here again is where we don't have a whole lot of choice about checking equations. Even if you did everything right up to that point, there's a possibility that we have what's called extraneous solutions because we're not working with the original equation. We're working with the square of that equation. All right? So that means the possibility of losing something, losing an equation. So when we put 17 back in there, we can see that it works out. Okay, does that make sense? All right, let's look at this. These here. Now, number 1 is set up to where we're already isolated with the radical on one side and the number on the other side. What happens when you square both sides? What happens when we square both sides of that? What happens when we square both sides? What are we going to get? I assume y'all are hearing me out there. I mean, I hope y'all aren't just trying to impress me by showing up in the participants list. You got to work our brains here. Like I said, we got just a little bit over 2 weeks. Good. X minus 1 is equal to 64. Good job there, Ross. All right. Now, it's really easy to solve this thing. It's just a matter of going back to our old, plain old basic equations. We're going to isolate x. It's not a quadratic. And that's not to say there can't be some, but I'm sorry, this is 65. All right. So x is equal to 75. Does that satisfy that equation? In other words, what happens when we check it? Is that a true statement? Square root of 64 is 8. So yes. Okay. Try that next one, see how it goes. I'll give you a couple of minutes on that. We got plenty of time to do stuff here. So so square both sides. I'm sorry, this is 81. 81 minus 1. So 10x is equal to 80. So x is equal to 8. But remember, we got to check. And I can guarantee you that there's one here. And I can almost prognosticate, not because I've worked this problems so much, it's just that by looking at them, there's a way to look at them, and I can tell you what it is you need to look for. But let's do them first because you still got to check them. You don't know what's going to happen. All right, so check. So that's 81. So just like the last one, we should be all right. All right, questions about that? Okay, see that needs to be isolated. Don't want to square it like this because the 2 is not underneath that radical sign. So what you're going to end up doing when you square that left-hand side, if you leave that over there, is you end up squaring that binomial. A lot harder to do it that way. So the good thing about on the side you're squaring, if you're just squaring that radical, then that whatever's inside is just going to pop out. All right, so 14, does that work? Well, you got to put it back in there to see. I think this one's going to be all right, but x is equal to 25. What am I on another planet? Five, and then 5 squared, 25. Well, I'm going to check that 14 anyway. Looks like it's right, but okay, so that's 18, I'm sorry, 14 times 2 is 28, minus 3 is the square root of 25. So 5 plus 2 is equal to 7. So that's it. So what happened, Michelle?
I don't know. I need to see. I don't know what happened. I'm I'm looking at it now.
Okay. I mean, it wasn't a mistake on the part of what I was talking about losing the solutions. It's a whole different issue. I have to see it. All right, so here's the last one we got for this. Like I said, they got relatively few. That's why it's going to be easy enough for us to finish things up. All right, we got a negative 7. And then this is going to be gone, and then you're going to have 4 take away 7, which is negative 3. And then we're going to square both sides. So the 5x minus 1 just pops out, and then this is 9. Any number squared is always positive. All right, you think we got a solution there?
No solution.
How do you know that? What are you seeing? Why is it no solution? Tell me.
There are no values. There are no values of x that equals the equation.
Well, we got one right here, but what's wrong with that one? What's wrong with that one?
1 second, let me see.
How can we find out if it's a solution? Because I came up with one, but how do we find out if it's a solution or not? We've done it on all three, so there's only one answer. That's the only one thing I haven't done yet. What have I not done yet? Yeah, I gotta check it. There's no way I can know because I guess you would say the general way is I got a solution here. That must be it. I did everything right, but that's not enough. We got to check it. I shouldn't have circled it yet because we said that's usually the last thing that I do. All right, so let's check that thing. The only way we can find out. So I'm going to check it up here where we got more room. So see, that's 10 minus 1. 2 times 5 is 10. So that's the square root of 9. Well, so now what's the solution for this one? What does that tell us right there? Remember, when you check a solution, you're supposed to come out with a true statement if it's done correctly. This one is not a true statement. All right. So, no solution. Okay. Questions on that? Because like I said, that's important, and they're always going to throw those in there. Because this is always a possibility. All right, good, Michelle. All right, so we got another one, and there's really not that many, so you don't want to get scared by the 7 because it's cubed. But so I'll just tell you, when you got a cube, you don't have to worry so much about whether you're going to lose solutions or not. And once you got them isolated, I mean, you just got to cube that one, and when you cube the radical, it just comes out just like any other one. Okay, so we got this is going to be this was going to be a mean one, but they're going to have an easier one over here. These are easier. Well, wait, that's not. Actually, 7 is the easiest one. I should have done that first. All right. So the reason what these are, and maybe you can see it already, you've got the radical isolated, but on the other side, you've got an x minus 3 that needs to be squared. So when you square the x minus 3, it's going to be the square of a binomial. If you know that formula, it'll be easier to do it like that, but you can still always FOIL it. So square this side, and the insides just come out. That's what happens. You're squaring because you're counteracting the square root. Those two things are opposite of one another. They undo one another. It's like multiplication and division. They undo one another. Addition and subtraction. They undo one another. They're opposites. And so on this side, it is a complicated part because when x minus 3 is squared, it means x minus 3 times x minus 3, which ends up being x squared minus 6x plus 9. Because it's x squared, 3 squared, plus, no matter what the signs are here, that's always plus because it's negative times negative. And in the middle, it's x times 3 times 2, which is 6x, and you take that sign, the negative 6x. So once you got that, then you gotta, unless you somehow are able to eliminate the x squared, which this one isn't, you gotta put everything on one side and then 0 in the other. It's slightly different procedure when you're talking about the quadratic equations. You gotta put them in that standard form. In other words, x squared minus 6x minus the 2x, and then the 9 plus the 3, and then we got x squared minus 8x plus 12. And then we factor it. So they both have to be the same sign, and that sign is negative. So you're looking for factors of 12 that add up to be 8. Only 2 do that, which is 6 and 2. So x minus 6 is equal to 0, x minus 2 is equal to 0, x is equal to 6, or x is equal to 2. Let's watch what happens on the check. All right, for 6, you put it in there times 2, you get 12. 12 minus 3 is 9. On this side, it was 6 minus 3, which is 3. Square root of 9 is 3, so this one's good. But watch what happens when we use x is equal to 2. 2 times 2 is 4. And then we got the minus 3 that was already underneath there. So that's square root of 1. And then 2 minus 3 is negative 1. Square root of 1 is 1. This one does not check. So there's only one solution. Before we go to these, let's just look at this one. I'll just set it up for you and you work it. This is going to be one of the easiest ones you've ever done. It's more like the ones up there. It'll be easier than these. Okay, first thing you got to do for all of them is do that. You don't want to have something added or subtracted to your radical. So we got a cube to get this out now. But the good news is, all that does, if you're matching the index with the power, is it just pops that inside out. And this is a pretty small number. So I'm going to let y'all finish it up, and then y'all tell me how it's going. All right, what happens on that one? So you're saying it's x is equal to 5 negative? Is that for this one, Ross? All right, so let's just see. So as I said, this just pops out. And then negative 3 times negative 3 is 9 positive, and 9 positive times negative 3 is negative 27. So what does it come out to? Yep, x is equal to negative 4. I'm sorry, negative 5. Now, here's the big question. Will it compute? Does it work? Will it blend? All right, so let's just go back up here and check it. Let's just say, because this is really the only way to tell. I can give you a little bit of help on when to spot some of them, but I'm not going to get into that unless you beg me for it. Because I want to make sure, because like I said, you can't tell all of them without checking. That's just the only way. And that's what I've got to remember. That's a cube root. Oops, I'm sorry. Oops, that's right. I don't know what I'm doing. So this is negative 3 plus 3, and that's equal to 0. 0 is equal to 0. So that's a good one. So to my knowledge, if there's a cube root or any odd root, which I don't think you'll have any in that, I guess it's possible, but you have to have a real small number on one side. But anyway, it's the even roots that have issues. All right, so let me set this one out. This one, it's already isolated. The problem is you've got the binomial over there, so you gotta square it. And like I said, use whatever method you understand. If you want to FOIL it, I like to use the formula from 5.6 or 7, whatever it was. It's called the sum of squares. So what happens on this one? Like I said, I'll just go ahead and write this one as well, because this is basically, these two are basically the same as what's up at the top. I mean, that second example. Oops, I should have put that there. Let me fix this. So when we square it, just the insides come out. I shouldn't have wrote it twice. All right. So square this side, the insides just come out. Square this binomial, then you get that trinomial. Pull it out if you don't see that how I got it, but it's exactly x times 9. Two of them is 18x. And this is that squared, and that's that squared. So this is going to be gone, and we got 0. All right, and I think that's pretty easy to factor. One's negative and one's positive because of that. The last number is negative, so the only way that can happen is negative times positive. So the larger factor is going to have to be negative. Let's see if we can figure out what it is. Oops. Did I make a mistake? I'll just do it here on paper. Oh, okay. I'm crazy. This is positive. See, negative 9 times negative m is positive, so that's good. Okay. So it's 84. 84. All right. Let me putting the negative there. So it's positive because negative 9 times negative 9 is positive. So I just need to change the signs here a second real quick. They're both negative. So it's 4 and 21. So 4 times 21 is 84, and then 4 plus 21 is 25. There we go. It took too much time, but that's what a little mistake can do. All right, so are both of these solutions? There's not enough room here. I'm going to have to go over to the old jazz board. So square root of x, 7x minus 3. All right, and then the two solutions were, let's just check 21. Oops. I don't know what am I doing this crazy stuff. All right. So we're checking 21 and x. So let's see, that's 21 times, is that 147? Yeah, 147. All right, am I doing it right? Because this one may be the one that's not working. So 147 is 144. Now that's right. So 7 minus 3 is 4. So then this is 12 is equal to 12. So that one's fine. All right, so the other one is x is equal to 4. All right. I bet you this one's going to be a problem, but let's see. Is this one going to be right? Is this going to yield a solution? Nope. So there's only one solution. All right, get a little start on that one, and then I want y'all to get on it so y'all can tell me if I'm doing something stupid. Because one little sign makes all the difference. So, any news on that one? So what's going on with this one? So I'm just going to square that out. If you want to, you can do it with the foil. 3 times x is 3x. 3x times 2 is 6x. And 3 squared is 9. That should always be positive whenever you square either a negative or a positive. And then this side just pops out. All right? X. And then this is minus 12. All right, that's easy to factor because it's a 4 and 3, you have a difference of 1. All right, so do they check? Give a minute on that. All right, so let's check x is equal to 3. Doesn't matter which one you check first. All right, is that good? I've got a feeling that this one might fall, but we're not 100% guaranteed of that. And the more I look at it, I'm going to say it's not. But the only way to know is just to check. What worries me is this over here is going to be a -1, and there's no negative sign in front of this, so I'm already suspicious again. So, no solution on that one, on that particular one. There's only one solution. All right, any questions about any of those things? All right, so that's that whole worksheet. So let's look at 10.7 for a little bit, and then we'll take a little break. The last section in chapter 10. All right. Now, we stated over in section 10.3, we stated that this is what? What did we say about it? Not a real number. Well, that doesn't mean that it doesn't exist. It's like when people see division by zero, they say, well, it doesn't exist, but technically it's undefined. It just means at this point we don't know how to define it mathematically. Now, with this, it's a little bit different because when we say it's not a real number, it's not any type of number that we've looked at yet, but above the number sets, and I'll kind of draw this out for you briefly. We've kind of looked at this all before, but we didn't go quite up this high. This is just all kind of theoretical. It doesn't really help you work anything out, but maybe it'll help you understand. This is what we call imaginary numbers over here, which is what we're going to look at for the most part. Imaginary, that's a number sign. And then this is the reals. And then we went on down the ways. Let's see, we had and here we have, what was it, irrational. And then this would include things like square root of 2, etc. Okay, there's no way you can write those as a fraction. And then you go down here, and then you got rational numbers. I have trouble squeezing this in, and that's anything that can be written as a fraction. This can't be, because a fraction by its very nature, it's got whole numbers on the numerator and bottom. And then we got, let's see, integers. And integers were just the positive and the negative numbers. And then we had, let's see, whole numbers, which include 0. And then we had the natural numbers. I'll tell you what, let me just erase all that and make it a little bit better. I'm just going to type it out with the text thing. So and then we have rational numbers. And then integers. And then there's whole numbers. And then down here is the natural numbers. And as I said, it really doesn't no big importance on, memorizing these, but each one of these essentially includes everything below it. As I said, this would be like square root of 2. This is anything is a fraction. This would be like -1, -2, 0, 1, and 2. all of the whole numbers, negative or positive. Whole numbers just means that it brings in 0. And then this one is just 1, 2, 3, 4. Doesn't include 0. So every time you go up from natural numbers, you're throwing in something new. All right? But above that is this a group called the complex numbers, and it's broken into real numbers and imaginary numbers. And again, you can't use the same definition that you would use in the everyday vernacular for this, because um, calling a real number kind of implies, okay, it's there, and an imaginary numbers that they're all in our head. Well, in a sense, these things are always all in our head. You know, the math is being done in your head. You're doing it without having to sort through a bunch of facts. You do calculations, and then you can fill in the facts that you know and come to a solution. So, this we said this is not a real number, but that's true. Well, we can still break it down using the property, and there's two sides to this. This I is not a variable. It works like a variable in most all cases, except for I squared is equal to -1. All right? In no other world but the imaginary number world can you square something and it be negative. On the real number side, anytime we square a number, it's positive. And then the counterpart is, let's see, the square root of -1 is equal to I. These are really both the same thing, because if you square both sides of this, you square I, and then you square square root, you get the -1 out. So, but that's the two forms you see it in for the most part. All right. Now, other than that, these numbers work just like any other kind of numbers. You can treat the variable, the I, like a variable, and so forth. But let's go through this example, and then we'll take a little break. But anyway, the square root of -75, notice that they factor out a -1, because that's the part we got to use here. And then the 25 is the perfect square, and then the 3 stays in. So the square root of -1 is I. The square root of 25 is 5. And then the square root of 3 is just square root of 3. So generally you do it just like you do variables. You put the coefficient first. So turn those around, and it's 5I square roots of 3. Now this one, the first couple of them, they're real easy. You don't have to do much. So what do you think what that first one's going to be? We're going to do these first two, and then we'll take a little break. Well, the way I like to think of it is the negative comes out in front as an I because of that. See, square root of -1 is an I. And then now you just got a 49 in there. And that's 7, so it's 7I. All right, what about that next one? The last one worked before a little break. So go ahead and tell me what you got on this. Like I said, the only thing that's different here is that I squared is equal to -1. So the negative sign comes out, and we got the square root of 16 left. The square root of 16 is 4. So that's 12i. So I'm going to say this. The only thing really new here are the two sides of the same coin. If we have if we have a negative sign inside of a radical, we just pull that out in front as an I. Now, technically, it's multiplying any numbers that are out there. So unless there's another I out there, you don't really need to do anything. Now, if that's the case, there's another I out there, I squared is equal to negative 1. So anytime you have an I squared, in other words, when you square a binomial, you usually end up with an x squared term. Well, not usually, you do end up with an x squared term. But if we have an I squared, then it changes to the negative of that I squared, and then you evaluate based upon that. And what that's just going to allow us to do is instead of having 3 terms, we're going to only have 2. All right, so let's take a little break. I'll see you in a few minutes. Okay. So, let me go back to sharing. Okay, so let me start sharing again. All right. So everything in this section is exactly the same except for 2 things. If you got a negative sign inside of a square root, then you bring out the I to fix it. The negative sign comes out in front as an I. And then everything from there on is exactly what we've been doing. So, look at number 3. Take a few minutes with it. See what happens. See if you come up with anything. I'm going to look at it and see what... All right, so what happens on this next one? Like I said, the best way to just fix it without thinking about all the where's and why for us. I mean, this is where it comes from. So if you got a negative in there, you just put it out in front and go from there just like we've already learned. So take another minute on that one and then we'll go through that. As I said, it's easy on that one. All right, you made it back, Michelle. I don't know what happened. Sometimes if you get kicked out, I'll try to go and click on the start again, and it'll say it doesn't exist or something. You have to refresh the page. I've had that a couple of times, but I'm not sure if that's what happened. All right. So this and this just so what does that make this? Fill in the blanks. Yeah, I saw you back. What happened? So what does this end up being? Square root of 4 is 2. So it's 2i square root of 5. The negative on the outside has nothing to do with the negative on the inside. The negative on the outside just means that this thing is negative no matter what. Okay, but I'm going to bring out the I, and then the negative sign is still there. So what can I do? Square root of 18 breaks down into 9 times 2. So there's going to be a square root of 9 that turns into a 3 out there. Square root of 2 stays in. Now this is the same darn one that was up there, so no, it's not. I'm sorry. Even I fell for it. So what is the difference on number 5? Okay, that has no negative sign on the inside, so that's just going to be negative I square root of 3. See this? It's just The negative sign was on the outside, so instead of an I, you got a negative sign. What about number 6? Won't run across any easier than that. There's not only one thing you can do. It's what I've been doing. Not much is going to be done. It's just I square root of 2. The negative sign comes out and becomes an I in front. Again, I want to bring the I out, and then I got square root of 72. And 72 is divisible by 9. Well, it's not just divisible by 9, it's also divisible by 36. So the square root of 36 is 6, and we're going to multiply anything that comes out, multiplies what's already there, so that's 30 I square root of 2. All right, so that's really all there is to simplifying these. You change your I inside of your square root, you take it out and turn it into an I in front. Now, the next section is subtraction, and you know what? What's that? Sorry, it's addition and subtraction. And you know what the good news about this is? Nothing changes. It's just like chapter 5. When we learn how to add and subtract, actually we may have even done it before then. It's at chapter 2, where we add and subtract little binomial values, and we collect like terms. Well, this is that same thing. You're going to pass that. In this case, it's a subtraction. So you pass the negative sign under the 7 and into the negative 3. So it makes negative 7 and plus 3, and then you put together the like ones. So it's 8 minus 7, negative 9 plus 3i. So 1 minus 6i. So sometimes you may end up with only a whole number, but usually you're going to end up with the real part and that imaginary part. This is the real part, and that's the imaginary part. So I'm hoping these will be pretty easy for you. So give a crack on number 8 and tell me what we have, because 8 is as simple as it gets, because it's just addition. So what happens on that one? I got no idea whether y'all are just hiding or this is hard for you. So I'm just going to add them up. 4 plus 9 is 13. 7 minus 11. That's all there is to it. Just like it was regular old variables. All right, now you just got to watch out with subtraction. because you're subtracting both of those things. So I'm just going to rewrite it as 2 plus 9i minus 5 minus 5 minus a minus 2, which is plus 2i. And then, as I said, is you're going to, we can do like that and just put them right next to one another. So that's going to be equal to negative 7 plus 11i. All right, questions? Like I said, they don't have that many of these because these are not really any different than just plain old, like terms type things. So this is 9, and we're going to minus the positive 5, and minus the minus 2i, which is 2i. This time there's only one I term, so it's just 4 plus 2i. And like I said, yes, this is what they call the real, and that's what they call the imaginary part. This whole thing together is called a complex number. All right, now when you multiply, we just, remember, if we had, in this situation, we had 2 plus 5x. And I'm just replacing the i's with x's just to kind of refresh your memory. Plain old FOIL. 2 times 3 is 6. 2 times negative 4 is negative 8x. Inside is 15x. And then the last is negative 20x squared. These two go together. And usually you kind of see it turned around, but you get my point. The x squared will be first, but that's not really so much the issue here now. Now, we're going to end up with I squared. So when we collect like terms with this, we're going to just simply have a real and imaginary that we can put together. So we got 6 minus 8i plus 15i minus 20i squared. Well, the one change we can make is what we learned up here, that I squared is equal to negative 1. So 20 times negative 1, what's negative 20 times 1 gives us a positive 20. Now notice that we simply put together these and these. So 6 plus 20 is 26. Negative 8 plus 15 is plus 7i. So take a look at those. We just got a few of these. All right, so you do it just like with variables. So if this was 3x and 6x, you multiply the 3 times the 6, and then you got I times I, which is going to be I squared. All right, are we finished then? Well, no, because we got an I squared. We got to change that to a negative 1, and that gives us negative 18. All right, so here it's 5I, it's a monomial times a binomial, so we got to do it twice. They're both positive, so that's going to be positive. So this is 20I. Oh, I'm sorry, this is I squared. Oh, we haven't done the I squared yet, I'm sorry. So 5 times 6 is 30. I times I is I squared. No I squared should stay in your final answer. They get changed to negative 1. All right, questions? Now, the one we're looking at is pretty much like the example, so it's just FOIL out. 5 times 8 is 40. 5 times a positive 5 times negative 2 is negative 10I. Inside is negative 8I. And negative times negative is going to be positive. It's just negative 1 times negative 2. Positive 2I squared. So the I squared, so that's going to be 40 minus 2, which turns it back into a real number, so it's 38. So really you're doing the exact same thing as in chapter 2 and then in chapter 5 when we ended up bringing in binomials and such, polynomials. And the only thing that's different is any I squareds get changed to a negative 1. If you start out with a radical that has a negative sign inside of it, and when I say radical, I mean a square root. I don't think you get into any even roots, but if they are even roots, then the negative is going to be in there and comes out as an I out front. It's not an issue with cubes or anything like that. Anything odd. All right, let's just do this one. We'll come back to that one over there. So 3 times 1 is 3. 3 times 2 is plus 6I. Inside is negative times positive, so that's negative. And then negative 5 times positive is negative 10 I squared. So this is 3 plus I minus 10. And this is times negative 1. I squared is negative 1. So this is 3 plus I plus 10, so 13. Okay, let me know if you got questions. So you can fill this out, but I'm going to use the formula. 4 squared is 16. 3i squared is 3i squared. I'm going to write it like this. I'll tell you what. Let me back up. I'll probably put too much. So 4 squared. And then it's 4 times 3 is 12. Same sign. And 12 times 2 is 24. I. So this is 16 minus 24i plus 9i squared. This is going to become that negative 1. I'll put these two together. Oh, that's already together. Whenever you use the formula, it puts it together for you. Because whenever you square, you're just going to end up with negative 12i plus negative 12i in this case. So 16 minus 9 minus 24i. So like I said, there's not a whole lot to this section because everything is the same except for I squareds become negative 1 and negative numbers inside the square root come out front as an I. All right, last questions on this. All right, we got 2 more sections to go. I'm going to just go ahead and just take a look at 11. Let's see how long it is. We'll get a little bit done of it, so that way we won't have such an intensive Thursday. Because this is fairly short. You could probably almost finish it today, but and just incidentally, see, it's not that long. And incidentally, let's just see. The other one is the quadratic formula, which I've got an idea that if anybody had an algebra course before anywhere, that you use this. One good advantage of this is that if you're stuck on the factoring, the quadratic formula will show you the solutions without having to go through all that. The main thing, though, we're going to do in 11.1 and 11.2 is we're looking at how to solve it's alternative ways to solve quadratics. And because sometimes quadratics are not factorable, but yet they still have solutions. So let's go over here and just get started on this. Okay, 11.1 is called the square root principle. Now, these are tailor-made for when you have a square value. It could also be a binomial with a variable in it, but you have a squared variable, and you can set it equal to any whole number. All right, so this one's missing a middle term. There's no x term. So actually, this is pretty easy to solve. And let me just kind of show you with another one first. Let's just say we got x squared and it's equal to 25. So this one's got is using a few things. Well, if we take the square root of both sides, we got to remember we got to throw in this plus or minus, because remember there's two solutions when you got a quadratic, when you got an x squared, and this is what helps us get those. So square root of x squared is x, and square root of 25 is 5. So x is equal to 5 or negative 5. And the reason being is, if you take 5 and square it, you get 25. If you take negative 5 and square it, you get 25. Okay? So here, it's a little bit more complicated. If we had this one would be easily to be factorable, because we would have x minus 25, which is x minus 5 times x plus 5. But if you got these methods at your disposal, you can use them, and a lot of times they're quicker than factoring. All right. So x squared minus 50. So we bring the 50 over, and we got x squared is equal to 50. So take the square root of both sides, and when we do that, take the square root of x squared, we get x. On this side, we got to put plus or minus in there, because there's going to be, remember, when you square something, both the positive and the negative will end up positive. So square root of 50, just in case you're wondering where that comes from, I mean, where that, how it gets 5, it's 25 times 2. So that's equal to 5 square roots of 2. And that's as far as it can be broken down. So you got the positive and the negative one. And you can go ahead and square this and find out that it's going to be your right thing, because if you squared 5, I'll just do it for one of them, but if you square this, that's going to be 5 squared, which is 25. Square root of 2 squared is 2. And so you see, it gives you the solution. And the negative would do the same thing, because negative times negative is a positive. All right, now, one of the things, like if you go into Math 130, there's this thing called completing the square, and that's where this comes in at. It's a really powerful method for solving quadratics. And not all for that, but for also for certain types of, I guess it's called geometry, where you, and then when I say geometry, I don't mean kind of you have in high school. It's kind of analytical geometry. In other words, if you want to plot circles and ellipses and what do they call them? I can't remember all the things. There are several different things called conic sections. But anyway, okay, this one. So you don't want to keep anything over there except for the square. So you're going to subtract 9, and so that means you get a positive 9 over there. So you take the square root of this, and it just comes out. When you take the square root of 9, you've got to throw in the plus or minus. The square root of 9 is 3. So we got two different solutions. X is equal to 5 plus 3 and x minus 3. So 5 minus 3 is 2. 5 plus 3 is 8. So there's the two solutions. All right. I'm not really up to going through any more of these. I think we got plenty of time.